It's my pleasure to welcome Skjold Søndergaard from Aarhus University, our department, and he will give us a talk on shifting baselines and this biotic integrity of temperate ecosystems, which is his PhD topic. So, Skjold.
Okay, thank you, Jacob. So pleasure to be here. I'm very happy. Jacob has been treating me very well. We were in the field yesterday. So I recognize some faces, so that's very nice. I'm going to spend some time now talking about the stuff that I do for my PhD. I work in a part of Aarhus University that's actually very focused on conservation. So turning sort of biological, ecological science into something you can use in conservation, producing tools that society can use. But I'm also at the same time lucky to be really able to travel out of Denmark in time and space, right? Because we want to make the aims, the conservation or restoration aims, as ambitious and scientific as possible. And for that, you do need to leave Denmark, because Danish nature is, even the best Danish nature is some of the worst in Europe. So it would be a very sort of sad restoration program if it was only based in Denmark. But I will get back to that, because that's obviously why I'm here now, because we are planning some collaboration where Czechian nature plays a very important role. But let's see. Do I have to, or am I out of the? Maybe I'm out of reach. Let's see. Oh, there we go. Okay. So, as Jacob said, I'll be first introducing our idea of biotic integrity. You can also call it ecological integrity, and then explain why we need to focus on getting the baseline right. And specifically, we'll be talking about temperate Europe. And then some of the evidence that we're using to inform our baseline and why we think this is a better baseline. So I'll be presenting some paleontological evidence and also some macroecological evidence. This is not my evidence. Well, some of it is, but it's something, that actually it's out there, this information, but we are just kind of gathering it and presenting it in a way that we make an argument that this actually points to a very different paradigm for natural vegetation in Europe than the one that's dominating. We'll see if it's also dominating here in this department. And then obviously come in on the role of vegetation disturbance and why this is a key element of this baseline for natural temperate vegetation, and then how we use this in our area-based conservation tool. And then finally talk a little bit about the field expedition. So basically, our idea of biotic, or not just our idea, but the idea of biotic integrity is that you can look at species. If you know a lot about species ecologies and their habitat requirements, you can use the presence of certain species, obviously, to say something about the environment. This is not new news to you, but that's basically the idea of indicator species, right? So, for example, this is a species of bee in temperate Europe, Osmia pelicornis. And if you find this bee, you know three things about the environment. You know that there is sun-exposed deadwood in the environment, because it will only carve out its own nests in deadwood that is quite warm and therefore sun-exposed. You also know that there is a large amount of pulmonaria in the forest, because that is the main pollen and nectar source for this bee. That's what it collects and gives to its larvae. And you also know that there is Fragaria, usually Fragaria vesca, in the forest, because when it's finished making its hole in the deadwood, this Osmia pelicornis only closes the hole with chewed up leaves from Fragaria. So you take out any of these from the ecosystem and the bee is gone. But if you have them, you can have the bee. And if you find the bee, you know you have them, right? So that's the general idea. This was sort of the idea of biotic integrity, ecological integrity, as it was developed in America, actually almost 100 years ago. And especially there's a zoologist, Carr, who was one of the first guys to use this for fish communities. So he said, what we know based on the fish species that are present in these freshwater systems, we can say this freshwater system is in a more or less intact state based on the species that are present, because of the things that we know about the species. And obviously, I'd say that this is a pretty good indicator of integrity, because this is a sort of a pretty rare combination of resources where you both have the woody old growth resources present, but you also have the herbaceous vegetation. So this would be, in my mind and in our idea, a indicator of high integrity, maybe even very high integrity, because we believe that this combination of the forest resources and the grassland resources, or at least the herbaceous resources, is actually a very old and very natural combination for temperate Europe. It's not so natural or common today, because usually we have forests here and herbaceous richness here, right? We have them separated, but we believe that back in the day they were mixed. And obviously what human impact does to biointegrity is that if we imagine a wild ecosystem as a space made of gradients, right? But you could have a moisture gradient, and you can have a light gradient, and you can have a fertility gradient, and then you have a box, right? And the larger the box, the more niches, the more ecological opportunities there are in the system. But obviously humans, when they come into an ecosystem, what we tend to do is we optimize it for our intentions, right? And usually those are something to do with producing something, right? Because if you don't produce anything, it's hard to survive. So we would, for example, to make this more productive system, we would drain the wettest part of the system and water the driest part, and we would fertilize it to make it more nutrient rich, and we would also make it more light open, right? So we would take this box and then reduce it on all sides until we have this perfect system that is optimized for exactly the plants or the livestock that we want to produce. And the importance of of that shaping is that as we shape, as we reduce the size of this ecological space, we also reduce the species pool that is relevant, right? Because as you reduce this box, a smaller and smaller part of temperate European species can exist in this box. So we would like larger boxes, right? Because we think that that's a bigger part of the species pool can exist there. It's not to say that small boxes don't exist in nature, right? So, for example, rain-fed bogs in a lot of the boreal zone. I don't know actually if you have them so much here in Czechia, but these very acidic, nutrient-poor sphagnum bogs, it is quite a small box. There are not great abiotic heterogeneity in these systems, and also the species pool is quite small, but it's still natural, right? So it's not to say that the largest boxes are the most natural. It's just to say that we humans tend to reduce the box always. It's very rare that we come into a system and enhance it. It can happen. And then finally, to get at this system, kind of this idea of biotic integrity, you need a baseline, because you need an idea of what is intact to measure intactness compared to what. So when you go into a system, you need to have a very good idea about what was this before human impact. And this is what I'm going to be talking. This is unpublished. We're working on publishing it now. It's in review. No screenshots. I can't stop the people online. But anyway, this is obviously reconstruction. So, but I'll get back to this. But this could be an idea. This could be an idea for natural temperate vegetation. All right. Very good. I'm just gonna. So speaking of natural vegetation, I asked. I guess you can barely see it here, but I asked DALL-E ChatGPT to make me a painting of primeval or primary European vegetation. I asked basically, what is your baseline? What is natural European vegetation? And it painted me this very nice sun's photo in golden hour. Could be Czechia, could be Poland, could be Denmark. Obviously, the point here is that this is more or less the dominating paradigm for natural vegetation in Europe, in temperate climates, actually not only in Europe, is the closed canopy theory, right? And this is based on mainly on two sources. One is a very...
Right, there is someone online who has the microphone on, so please switch it off. Yes, thank you.
Yeah, watch out. That's dangerous to have the microphone on without knowing. But one evidence is the very real evidence of if we all went out and just chose a plot of land here in Czechia and abandoned it and did nothing. It goes in one direction, no matter what, and that is towards a more woody-dominated state. Right? It becomes more and more dominated by woody plants, and this is a well-known phenomenon for hundreds of years in temperate climates. The other source of evidence is this fossilized pollen. So this came in later, but it basically supported our general idea of what happens when we abandon, what happens to natural nature in temperate Europe. You have time going back on the y-axis. This is from southern Sweden, but this is the same sort of pattern in all of temperate Europe, pretty much. And then you have the percentage cover of these different types, right? So you have conifers, deciduous trees, cereals, non-cereal grasses, and other trees. And what you see is as we come out of the last ice age, very quickly deciduous trees take over. And based on your method, I mean, the reveals method nuances it slightly, but still the pattern is the same, right? You have the dominance, more or less 100% dominance of deciduous trees. That's what you see in the Holocene. So it's a very reasonable thing to think that surely closed canopy forest is natural vegetation in temperate Europe, right? And then obviously something happens here. This happened later in southern Sweden. It happened earlier here in Czechia, and it happened even earlier if we go south. But obviously agriculture arrives, right? And then you see this, especially when we start producing cereals, we see a big change to the vegetation structure. And this is and this basically has produced sort of this is the foundation that we build plant ecologists in temperate Europe. This is the foundation we build our ideas upon. We say natural vegetation is closed canopy forest. Then we have this light open vegetation. It's strange, it's very diverse, but it is somehow cultural origin. And basically, this is a graph, or this is a figure from a paper that we published this year. But basically, the idea is, right, that we have this past where it's all dominated by trees. And then around 10,000 years ago, right, the first agricultural humans, first with livestock and later with cereals, basically, here comes the grassland, right? The grassland starts to replace the trees. And then this is an important point, right? This is around the Enlightenment era, right? Alexander von Humboldt, these big European plant ecologists start developing their ideas here, right? So they don't develop them 10,000 years ago. They definitely don't develop them 50,000 years ago. And that's probably an issue because this has big consequences. This is from the UN Secretariat of Biological Conversion. And what you can't read here is it says approximately 50% of European species are dependent on agricultural habitats. And so that's half of European species, they say, are associated with agricultural habitats. So this idea, this paradigm becomes politics, right? So what do you have to do to save? If I'm worried about European species, well, I guess we need more agriculture or more of a certain type of agriculture. But obviously, if I remove this, what's hiding behind the tree? What's hiding behind the tree is the fact that for all of the Pleistocene, up until the late Pleistocene, around 5,000 BC, you have a dominance of extremely large herbivores. Actually, some of the largest herbivore assemblages in the world, right? And this doesn't at all only go back 2.5 million years. If we take even a further look back in time, this is from a study of Carsten Svenning and colleagues from last year. What you see here is we have millions of years on the x-axis, and then we have maximum body mass on the y-axis. And obviously here, 66 million years ago, we all know what happened there, right? Something bad happened. A meteor struck Earth and wiped out dinosaurs. So we dropped from very, very large animals to sort of small animals. But also what you can see is the recovery was pretty rapid, right? So from day one, almost, it looks like mammals started getting bigger and bigger and bigger. And they've actually gotten bigger and bigger and bigger ever since, until something happens. This is the late Pleistocene. We can't even put it in the graph because the time, it's such a quick period. It's these 50,000 years. In this scale, you can't see it. But in 50,000 years, pretty much all over the globe, this happens, right? You go from a mean body mass of mammals. So the average mammal was over was, maybe like 350, 400 kilos. And then you go to an average. This is per species, so not abundance, right? This is not the average, but this is per species. You go to 150. So you basically have the size of all mammals on Earth in these 50,000 years. And also you can see the gray lines. That's Europe, and you can see actually that we are winning for basically the majority. We are the place on the planet with the biggest animals for almost all of the Paleogene and Neogene, right? It's not Africa, right? It's not America. It's Europe, right? The biggest mammals. And this is also, so for the plant ecologists in the room, this C part here shows the first fossil appearance dates of extant tree genera and species. So all species of trees and all genera of trees on the planet. This is, and obviously, first fossil appearance is not the actual time of evolutionary origin, but it's the best proxy we have. So, and what you can see is that half of extant tree genera and most species appear in this period, right? They evolve in the Paleogene or Neogene with the presence of these humongous mammals, right? So that's basically the conditions that you have to be able to adapt to when you evolved as trees. So these are all the tree species that we know, and they all evolved. None of them, very few of them, maybe one of them evolved in the late Pleistocene. All of the other ones were Miocene, Pliocene, right? So they're old. The plant species that are around us are old species. And if you look at paleontological evidence, this is also from a study, this is from 2023, but also from Aarhus University, and use the same pollen analysis as I showed you previously, but looking at the last interglacial. So not the last glacial period or this interglacial, the Holocene, but you jump back to the last ice age and then back to the last interglacial. So when climate was similar to now, what you find is if you develop these three categories, open vegetation, which is literally heather, forbs, and grasses, or light woodland, which is oak, corylus, these, or close forest, which are conifers, or beech, carpinus, all that. You see that in the early part of the last interglacial and the late part of the last interglacial, for temperate forests over here, right, you have around 20% that's actually closed canopy. And then you have this huge part, obviously, which is this oak hazel forest, which is what's painted here, right? This is a reconstruction again, so we didn't go back in time and take these photos, right? This is artist. And then you have around 20% literally grasslands and meadows, right? Where you would see maybe this, this is a carrot meadow, or this is a grassland. And it's obviously the trees, the closed canopy is up to 50% in the late part, but still it's 50%. It's 50% light open, 50% closed. So a very different pattern than I showed you from the Holocene, where it was 99% closed. So and the point here obviously is why we look at the Eemian interglacial instead of the Holocene is the key point is there are no humans in this. Well, there are Neanderthals and there are maybe a couple of Homo sapiens also, but there's basically no real impact of humans, at least not compared to the Holocene. So we believe that this is a better baseline, even though it's further back in time. But I hope that you see that going from taking a baseline that's 10,000 years ago or 100,000 years ago, in the light of evolution of the species we're talking about, that doesn't matter, right? It's the same species, exactly the same species that dominated the interglacial, the last interglacial that are present today. And the point is you can take this further. So this is from the same paper that's also in review. Basically, we had these large megafauna. We've had elephants in temperate Europe. If switching from one species of elephant in warm periods, another species of elephant in cold periods, going back 18 million years, right? So 18 million years of elephants in Europe. It's actually one of the places with the longest continuity of elephants in the world, longer in Africa than Africa. And what you can see, this is a reconstruction of, if you go back to the Miocene and Pliocene, the species are not the same, right? We have different species. We have sequoia, we have We have different species of cypresses that are only present now in the Americas. But we do have elephants, and we do have some of the species. We do recognize some species, right? Here's Sanguisaurus, exactly, very good. Plantago. And if you go to the Eemian, it's literally the same species that we have today, right? So we have European hamster, corncrake, black grouse, equium, papava even. We have there's evidence of papava. These are all species from lowland Poland in the Eemian. There's papava ores in fossilized pollen from the Eemian 100,000 years ago. And I'll tell you, there were no cornfields in this period. That's absolutely certain. But still, there was papava. And I'd like you to think about that and come up with me after the talk and give me an explanation for why there's papava I mean, surely it must be a mistake. And then obviously this is just Dali. I told her to make a old growth beech forest, because then the idea is that we have this short period where something happens, right? And these close canopy forests are having a really good time in the Holocene, a better time than they've ever had, probably. And then we get to here, right, Holocene agriculture. And the point of these photos, obviously, is that there is a continuity between this photo and this photo, right? The papava ores, the European hamster, right, and all the other species, European hare, all that. So that's the paleontological evidence, but we don't have to just stop there. And I have to make sure that I'm on time here, because I'm okay. This is I think this will be well known to you guys. So this is one of the reasons why we're very interested in being here, right? Here we go, Czech Republic, represented. You have these insane records from your grasslands. And if you believe in species pool theory, this should be something you should question. So why? Why is it instead of temperate grasslands, why is it not tropical grasslands? What's the reason why tropical grasslands are not the richest on small scales? Why in the world is it temperate grasslands? I don't know if any of you have the answer to that. Because what we see here is obviously when we go up, then we switch to tropical forests. So we believe that, and obviously also the richness, the species here, mainly forbs, right? So it's specifically temperate forbs that are really the key driver behind this incredible richness on these small scales. And this is another way to look at it. So this is also from I think this, you'll have to see this, the DOIs are hidden here under this, the links. But this study compared this was an American study comparing temperate America to tropical America, and then looking at plant functional forms and diversity. And so we have these three, we have tree, shrub, liana, herb, epiphytes, tree, shrub, liana, herb, epiphyte. And what I'd like you to pay attention to is that if we look at this center, then we see in temperate America, 83% of species sort of realize their life and in the herbaceous or in the ground flora, right? Whereas in tropical America, it's much more, first of all, it's much more spread out, but 50% are sort of this intermix between small trees, lianas, shrubs. And this is the same pattern in Europe, and it's the same pattern in Asia. So this is a temperate pattern. So it doesn't have anything to do with species that are lost due to glacial cycles. We are poorer than the Americas and Asia in regards to temperate vegetation, but it is the same pattern, right? So also in nice temperate, for example, in temperate China, they have more species of trees than we do, but still the large majority of their plant species are in the herbaceous layer, and it's the same for America. So this is a strong pattern, and obviously the point here is that you look at paleontological evidence that seems to indicate that light open habitat has a continuity in temperate climates, and you look at these patterns from diversity, evolutionary patterns, and you see this pattern doesn't kind of just randomly exist. If you believe in species pool, you would say, and you also think that forests is the natural vegetation of temperate Europe, you would expect to find this just for temperate forests, right? You would expect to find the majority of species as small trees or shrubs, But that's not what you find. You find all the species are in the ground vegetation. So basically, we are challenging this paradigm and saying, no, temperate light open habitat is not of cultural origin. We'd like to nuance it more, right? We'd say these two vegetation types are equally cultural, right? This is both vegetation types that have emerged because of human impact, right? So and this separation is unnatural, right? So we believe that these two species pool, light open species pool, closed canopy species pool, they've actually coexisted for millions of years in temperate Europe and in any temperate climate. But we have just always underestimated the effects of these guys, right? Because they're hard to talk to and investigate. We know more or less what these guys do, right? We all have them. My grandfather, for example, he's this guy. But this guy, you have to go back pretty far in the family line to find that guy. But obviously, the point is they like to eat these guys, right? And they like to eat elephants. And when they did that, disturbance fell. So this is not for publishing. Okay, this is just a very rough sketch. And vegetation disturbance is obviously more nuanced than that. So you have to at least part it up in frequency and intensity, right? But so bear with me. This a general idea of vegetation disturbance and a general idea that there's a continuity in Europe, right? Because we have these large megafauna, we have fire, we have flooding, we have all this. There's no humans kind of changing things for 20 million years, right? And then something happens. For 40,000 years, it took humans 40,000 years to pretty much empty the whole planet of large megafauna. Right, we were hungry children, and then we have this period, right, where something then there's a new shift in direction. Suddenly, we develop all sorts of methods to disturb the vegetation again, right? So we developed the saw and the axe and the scythe and the plow, and here we go. And the point here is this line shows that this would be a natural sort of disturbance regime, and that these different things that we now do in our landscape more or less comes close or comes far to this naturalness. Don't think too much about the distances. The point is just extensive agriculture is closer to the natural disturbance regime than the other two, right? So obviously there is intense disturbance in the forestry, but it's not very frequent. It's intense but infrequent, and then you have decades of no disturbance. And obviously intensive agriculture is extremely frequent and extremely intense. So extensive agriculture is this sweet spot. Not a sweet spot, but it's at least the closest that we get. And that's obviously why we are interested in this sort of landscape, right? Because this basically shows us that we should not look for untouched ancient forests in Europe, and we should not look for intensive agriculture either. We should look for something in between. When we're looking for, obviously there is no, also I hope that the point is clear, there is no intact vegetation in Europe, right? Because even though we wanted to have these big animals are gone, right? So we don't have any unless you. I mean, we'll see what you show me tomorrow, Jakob. But as far as I know, no elephants in Czechia either, right? And if you've been to Africa and seen what these elephants do to vegetation, you know that is a pretty damn big change to make to vegetation. If you remove these elephants, you cannot expect to have the same type of vegetation afterwards. So there is no intact vegetation, but we believe that this is a theory that these extensive agricultural landscapes in the Carpathians are possibly the closest we can get. So with that idea, this is what brings me to what I actually do. So this is the Danish Nature Indicator. This is Denmark, and the darker pink shows areas that we actually consider to be both quite intact and in a good state in regards to kind of nature protection, but also to the processes that sort of should be able to maintain this level of diversity. This is a zoom in on a Danish island where you can see sort of what it looks like. It's very fine scale, 10 by 10 square meters that we've mapped this. And the point is we're working with three things. We're working with integrity, which is the thing I've explained so far. So this idea of how close is this system to a pre-human baseline, and then protection is literally jurisdictional protection. So what law is protecting this area from the threats that are common for this biodiversity? Could be Natura 2000, for example. And then processes represents these kind of natural sources of disturbance that are most commonly changed by humans. So that could be draining, right? If interfering with natural hydrology. But it could also be, we have a lot of flooding from the ocean, or it could be sand drift. So that's also actually a natural process in Denmark. We have very rough seas here to the west coast, which produces dune vegetation, which is some of the only like really impressive nature that we have in Denmark. But we do all that we can and have always done, and grazing, importantly, grazing also as a natural process, or herbivory. But we do all that we can to limit these things because they are annoying and dangerous, and you can't make. So if a huge sand dune comes and covers your house, you're not interested in that. If a wildfire burns your house down, not interested in that. Flooding, also not interested in that. So we, like any other place in Europe, have done all that we can to limit these processes. But we believe that you can't expect to be able to conserve biodiversity in a place if you don't have these processes, because that's some of the disturbance, some of the dynamism that sustains these. So basically, yeah, we part it up in these. So we map natural processes, we map legal protection, and we map biotic integrity, and you combine them into this map. And it's at this point, it's a very simple combination, right? So the aim of the project is to assess area-based conservation. It's basically a tool that's supposed to guide people that want to protect and restore diversity, right? So you use this to find out where are the good places, where is the high diversity, where are the rare threatened species, and then these are the things you change. So you restore processes, right? You restore hydrology, you let out some grazing animals, and then you protect it. And when you do all these three things, we believe, okay, then there is a future for this ecosystem. If you have nice stuff and you have processes but haven't protected it, you can change it all next year, right? You can build a shopping mall. And if you have integrity and protection but no processes, we know where this system will go, right? It will go into a more and more woody-dominated system. So that's the general. It's a very simple approach, but we believe it's very good, and it's also importantly a little bit of a change of the point of conservation, because now we're not so focused on the exact kind of habitat type of the area. We're more interested in, is this system semi-intact? Is the conditions for kind of native species diversity present, and have you protected it and restored the processes? And then it's sort of actually setting it a little bit free. So we're not too worried about if it then develops into something else, but we're just interested in, have you found the right place and done the right things? If you've done that, then you get a lot of points in the system. And this is some examples on this island of Læsø. You can have this example, for example, of pretty high, above average, going from 0 to 100 integrity, average protection, but very low processes. Let's say this area is still drained or there's no grazers. Then your final score becomes quite low. But it's also very obvious what you need to change here to make it very high. So I hope you can see how this system sort of incentivizes the right things, right? It incentivizes that if people want to protect biodiversity, that they'll do it in the right places. Because if you have a place where it's integrity 2, could be a field, right, and a recently plowed field, you can protect it and you can restore it, but you're never going to get very many points, because in the grand scheme of things, you should have probably invested your money in a more valuable habitat, right? So it's about investing restoration, energy, and money in the most valuable habitat. That's the point of it. So here you see very high integrity, but also the score is held back by mediocre or not 100% protected, so not strictly protected, and also some processes that are missing. But so, let me see. I'm doing very good. So this is where I come to Czechia and the Pericarpathian forest steppe, because I hope that it's now semi-obvious to you guys why I'm here. Right, it was a long journey, but now we're back. So this is a photo I got from a Romanian contact. So this is somewhere in the Transylvanian plateau, and I would be lost, I think, in this system. There's a lot of species I don't know, but my point is that this might be the closest. If we aim to go out and look for this, because we can't find this, right? As I said, this is impossible to find. So we can look for this, and this might be the closest that we get to this. So this might be the closest to agriculture in Europe 60,000, or not 66,000 years ago, 5,000, 4,000 years ago, is these extensively used woodland, grassland mosaics in the White Carpathians, in Transylvanian Plateau. And we want to come to these places. We want to sample the vegetation. We want to sample some soil for eDNA analysis, get a general idea for our own sake. You know, how is it that these systems support such extremely high diversity? Obviously, it has something to do with the management. What about the soil? If I sample soil from the best Danish place and I sample soil from the best Romanian place, what's the difference? What's the difference? Are they very different? Are they very close? To get this idea of what should we be able to expect in Denmark when we restore our ecosystems? Can we expect to get this, or will it be completely impossible? And now I think maybe I destroyed this. So there we go. So this is our field expedition. We're a great undertaking in June, where we'll get in a car and drive to the Transylvanian Plateau, where we meet some local experts, and then we take a week, which is a short time, to sample some of their best systems. And we want to see obviously light open systems with extreme richness in plant diversity, but we are also using some insect indicators like the Osmia pelicornis that I showed you, that has this unique combination of both relying on old growth resources, usually for the larval stage. Could be longhorn beetles, could be scarabs, could be click beetles, or hoverflies, or butterflies, or bees, to lead us to the very best forests. And then we are using plant species diversity to lead us to the very best open habitat. And then we are going to Biotic in the middle, or in the second week of June, and then we're ending up with a lowland. Obviously, we would have loved to sample only lowland sites, but the problem with lowland sites is they are pretty easy to plow. So there's the integrity in lowland Europe is even worse than in higher regions of Europe that are more difficult to get extremely heavy agricultural equipment on. But we have an idea that this river valley in northeast Poland, we've heard rumors that it's supposed to be pretty good. So we're looking for some periodically flooded systems there to sample. And then finally, I'm so sorry. I think I really broke this.
Yeah, so I will change.
Yeah, this was a video, but now it's a PDF. So this was now stacked. This is my garden in Denmark, because what I also do, I focus a lot on, so this is the paper I mentioned. This is basically what I presented today, and this was published only a couple of days ago, because we are very much interested in the effect of grazing. Because as I hope you see that we obviously believe that these large mammals, herbivores especially, are very important for temperate vegetation. And this is the winter in the garden with some Highland cattle. Because what we found is that the effect of these cattle in the winter especially seems to push grasslands from grass dominance to fork dominance. So this is some of the stuff that I work with, and so please feel free to write to me, and then we can discuss more if you have some things you'd like to send, and obviously we can also talk today. But I just say thank you, because that's all I have actually. So I hope that was entertaining.
Thank you for this inspiring talk. I enjoyed it. It was so catchy, and I think so. I think definitely there will be great discussion. It's your turn.
Yeah. Well, yeah. I can't imagine there's no questions.
Many of them. Yeah. And it was a great talk. I want to just a couple of brief notes. Then, first of all, you are not alone. We have a rich community of people that have exactly the same mindset. They want to put the big stuff in the wild.
Yeah.
You probably heard of. And one thing, if they put that in, they can control the forest, not the shrubs.
Yeah.
So you mentioned that shrubs are not evolving here, but if there would be the big mammals, we would probably expect more shrubs.
Yeah.
Then another thing is that, I would like to, if you put in your presentation also climatic changes, because most of these changes are driven by climate. You have very warm and humid in Eocene thing. Then you have the climatic changes through the Pleistocene. And especially in Europe, the most or many extinctions you can very well explain by the climatic changes. So if you have a look on the fossil of mammoths, they by the change of distribution, contraction, retraction, they are really nicely follow the climatic changes. And especially the younger Trias was the bottleneck for those. Sometimes overlap with humans, but the climate was quite important at least, for like making the population very small, and then you can just hunt them down.
Yeah.
Like these Equus, the very last individual was eaten by the hungry soldiers in Poland in 1918, something like that. So this one was extinct because of humans, but then, you know, most of the population was reduced by the climate. So the climate is important. And then something that we also mostly forgotten is that I think this situation referred to lowland and flatland, but in higher elevation, more rugged terrain, completely different story. And for example, I'm a snail expert. So in Central Europe, like 80% of species poor are species of very dense forest.
Yeah.
So they're had an optimum in the middle Holocene, and you don't have a few species of grasslands and open habitats. So this group definitely evolved under dense forest. So they had to be off over the same period of time, because as for the big trees, most of the species, if you have a good fossils and molecular data, basically you date them 30-50 millions back then. So that's the ancestral origin. So they evolved at the very same spatial scale.
Yeah.
So yeah.
But
and with the white Carpathians, then if you're interested, I can send you the perspective of land snails, because we have a good reconstruction over the Holocene, and it shows that this country was more forested, and there was a patches of open grasslands and then very dense, richer forests, and both were, well, some of the grasslands habitats or patches were not depopulated, but the forest fauna was highly depopulated. So I think that like the current state we are seeing is definitely like more human-driven areas, but there was a long continuity since the last glacial, definitely. So there are, you know, two ways where the nature was developed, and both ways were kind of impacted by humans in different ways.
So first, regarding the extinctions, I mean, this debate is also still going on in Denmark. We have sort of Copenhagen University that's very focused on ancient DNA. So they've looked a lot in Siberia. They looked at mammoths and woolly rhinos and this Ice Age megafauna, and they do find that you can do modeling, climatic modeling, and especially the effect of climatic stuff on vegetation, that shows that basically provides likely scenarios for climatically driven extinctions. But the point is, and I think now this works, the point we make, for the reason why we think that it is also a mistake to focus too much on the climate, is that this happens globally. Also in climatic zones like the Western United States that were more or less completely climatically stable all the way through the Pleistocene. So you, and also, for example, on Australia, which was dried, but not more dried than in the last glacial cycles. So we rely much on the global pattern to say because when we then look at global climate modeling, the only thing we can get to fit the extinction pattern is more or less the arrival of humans.
But no Africa, no Southeast Asia.
Yes,
so you have
exactly.
Out of 5 cases, 2 didn't work.
And also, well, it does work in Southeast Asia, but it's true that the extinctions is less strong in Southeast Asia and also less strong in Europe, actually.
Oh.
Stronger in Australia and the Americas. And our point is there that these are the latest arrivals of humans, right? So this is the most modern human. It's the naive biota. argument, right? That we have.
Australia 50,000,
Yeah,
North America 14,000. Big difference.
Yes, it is big. It is big difference, but the impact is also most extreme in the Americas. That's the most extreme. With Australia, the most extreme is in the America, and more extreme in South America than in North America. So the argument is that
no, South America is the most evaporated.
Yes, yeah, that's where the impact was strongest in South America. Yeah. But the problem is you can explain this impact with climatic factors. So the South American extinctions, nothing happens climatically around 20 to 10,000 years ago that explains that all these big mammals disappear. So, and if we can do it, and obviously the argument is if we can do it in South America, we could do it in North America, we could do it in Australia, and we could also do it in Eurasia, basically. And the reason why we haven't done it in Africa is that Africa, unlike all these other places, Africa has had millions and millions of years, the African fauna, to evolve with the slow evolvement of humans.
That's the whole story all again. We were hungry, but not that much in Africa. And they can hunt the elephants.
Yeah.
Their culture, they can hunt the elephants much more than North American, European. They could hunt the mammoth. That was a very special case. There are not too much evidence that they really hunt the mammoths. But the Africans, they developed to hunt elephants. Still, they were unable to wipe them out. So this is the argument that don't work for me. It's a very shortcut.
Okay. Well,
you have n equal 1, and I have my South Asian example, and the rhinos and the elephants survive. So
I'll send you a lot of studies then after this, because this has happened all in the last sort of 5 to 10 years. We've moved a lot, and we especially, as I say, rely on, you cannot do global climate modeling fits extinction patterns very poorly. So
I don't think so.
Okay, well, I'll send it. I'll send you the research then. But this is
because then you have the LGM, which was probably the most severe climatic event over the whole Pleistocene.
Yeah.
And then before that, there was a kind of a very specific also climate for like 30,000 years of these dramatic changes that shaped the fauna to kind of, some might call it, Pleistocene safari, very stable glacial conditions that favor a very unique fauna. And then came the LGM. Some of them died out or extended during the LGM, was very severe. And North America was very glaciated, so also big change.
Well, especially the north of North America.
The north, sure.
So I know these arguments very well, right? Because the discussion has been going on for a long time. And I would say to nuance it that we had 46 almost glacial cycles, right? And it's true that the last glacial maximum was the worst, but it was not twice as bad, right? And somehow all the big mammals disappeared. But
that's my example with the last horse.
All the Euros, I guess.
If this climate change retry the population to drop them to 80% out of it to 20%, okay, then humans may do the change.
Yeah.
But if you look at the landscape level, what's the changes? So then, like reduction to very, small population density. So that's, humans important for the extinction, but the climate important to the continental level changes and the changes of the impact of these herbivores. And with the mammoths, the story is that, and it's 4,000. There was a small population in the Wrangel Island, and there is no evidence that humans just wiped them out. So, if they kind of managed to survive, and there was a next glacial, the island would be connected with the continent. They just spread out back to their original size, and we see no change again. So no, I'm also aware of these arguments, and what always make me a little bit sad is that it's flattened just to the humans, and I know you also didn't mention the climatic changes. So I'd like to see more about the climate. It's also important.
Exactly, it is important. So it's a dual threat, no doubt about it. And I'd say even though the argument is not over, right? This point here is still important. Actually, it doesn't really matter what killed the megafauna, because obviously there are none of these species that are adapted to planet Earth without megafauna. So it doesn't actually necessarily for conserving biodiversity. It's another argument. It doesn't actually really matter if it was mostly humans or mostly climate, because this lack of disturbance is likely causing kind of ecological changes that are completely novel. But it's very good, and I hope that also you can see this is a hot field, very exciting.
And the last thing you said, that it's not important if the human just extend or the climate, I totally agree. But for some reason, you know, the guys who are just talking about the effect of megafauna, always starting like, we are hungry, we kill them, we have to put them back. Never mention the climate, never mention that it doesn't matter. Even just talking, okay, we kill the mammoths in the Czech landscape, but they wouldn't be here because it's different climate. They would go to the north. So for the White Carpathians, mammoths are not relevant at all. Even they are talking about them, you know.
Yeah, but there was also, I mean, the mammoth, right, was small compared to the straight-tusked elephant, right, that was here in the warm periods. So that was 12 tons, which is 3 times the size of the African elephant. The mammoth is actually a little bit of a small creature compared to this. So obviously this is not only Ice Age fauna, this is also in
Paleozoic, they got extinct before the humans. Just make the.
Oh, it actually no, it didn't. So it is in this 50,000 to 40,000 years period that we have the final finds of this. So we actually have, as far as I remember, we have Paleontologodon bones with arrow splinters in them.
Sorry, we are on the bottom.
We are on the money. But the point is, the sexuality is very important.
There was more about zoology.
Yeah. But the point about the closed canopy forest and the snails, that's a very important point. So in this find, they did find that when they sample lakes from alpine regions, right here, as you can see, very close canopy. And that is mainly because if you've ever seen a video of an elephant trying to go up or down a slope, it's terrible. So they almost always injure themselves and fall. And we can all see that from Africa, that topography is very important in driving where elephants are, where they have and where they don't have an effect. So I'm not saying that closed canopy is not natural. As you can see, even in temperate, more lowland areas, it was there 50% cover in the late temperate. So that's I'm not shocked at all by this patterns from snail evolution. Any other questions? Yes, yeah.
Actually, I have another point which is actually similar. We found that actually with this like diversity of forms and herbs in general, there is also one aspect which is completely natural, and that's the continuity of the Eurasian forest steppe. Yeah, so that actually during the ice ages, okay, that there was a big migration from north to south and vice versa, which was hampered by the Alps. And that actually led to the extinction of 3 species. But there is a really good possibility to migrate to the west and east. So, and as a result of this, we have like a lot of species of continental origin, and there has been kind of like continuity of this type of ecosystem, which is one of the reasons why we have this high diversity of herbaceous species. So that actually goes to your like species richness records. Yeah, because without that we wouldn't have it.
Yeah, so this I'd say even here I'd like to challenge Jakub, because this is good, right? Because yes, so the idea, the steppe center of evolution, immigration, sort of this idea, I'd say that at least if you, as I said, if you put the species pool theory down on this idea, then actually, let me find the the reconstructions of the Pliocene, Miocene. With this idea, because obviously this is not just, this vegetation is not just, it did not originate in the Pleistocene. So it has a deeper time scale going back in the Pliocene and the Miocene. And with this, if we believe in species pool theory and say that the larger extent in space and time an ecosystem has, the more species are adapted to it, right? This idea that evolution takes time, so you need an ecosystem for a long time in a lot of places to have very many species. I'd say that if this idea is correct, then you would expect to have this species pool, this forbs and grasses from the steppe region, nice and big species pool, but you also expect to have a nice and big temperate humid vegetation species pool. And you can say, well, in Europe, the glacial cycles were extremely rough. And we also have evidence that temperate Europe lost a lot of tree species. But as I said, this pattern holds for all temperate zones. Also, for example, in Asia, where the extinctions were much more moderate. Really, a large part of temperate humid Asia was not even glaciated. And still in this region, you find this pattern. So in my mind, that says no, this is not the case of this huge steppic pool that then sort of goes into temperate climates, goes out of them, goes in, goes out. What we're proposing, and I'm sure, I mean, this is you guys are going to be my reviewers. So you're probably never going to allow me to publish this. What we're proposing is no, actually, these species had a continuous existence in temperate. So we're taking temperate forbs and grasses and bringing them home, right? We say this is not some foreign invasive species pool that is brought by agriculture or natural immigration from steppic. We're actually saying there is a continuity. So Tolius europaeus have been standing there by the riverside in temperate climates for as long as it's been a species. So hundreds of thousands of years. That's the radical thing, but it is radical. So, but I'm basically this is informed by looking at these patterns, comparing temperate regions. So if we look kind of beyond Europe, where it sort of fits, right? Because I mean, it's almost like a complete erasure of what the glacial cycles, at least in Northern Europe, did to us. So we can expect to, I mean, it's crazy. But if we look at, for example, Asia, where it was much more stable throughout climatically. I mean, it was drier, obviously, but there was no glaciation. You don't find this huge, beautiful, temperate, humid vegetation species pool. It simply doesn't exist. And we believe that there's a reason for that. It's not because obviously temperate climates could in a lot of continents just move, for example, in South America, move up and down the continent away from the glacial cycles. But also in Argentina, Argentina is featured on this map right there. So mountain grasslands in Argentina, it's the same pattern on both sides of the hemisphere. And I'm not sure why this is the pattern, why it is that especially temperate zones should have such a rich especially for species pool, but I'm just saying this is a global pattern. And I'd like to think that actually provides it some strength. So it's not a niche kind of result of crazy glaciation and agriculture in Europe. It's actually more like a real deep time evolutionary pattern. And it is a big kind of, I'd like to think that this is a big kind of attack on the closed canopy theory, because this just simply does not make sense when you combine this with the closed canopy theory. But I hope that at least you see that this is there's some novelty in the science, because I hope to not just come down here and as a botanist, because botanists, you should never trust a botanist. They just like their grasslands. So I hope that this is actually some arguments that no, grasslands are not just something we came up with in Europe. They've actually obviously grasslands not as we know them today, but I'm saying a mix of woody and herbaceous vegetation continuously covering, and with more closed in more rugged terrain, or just also random. I mean, I'm not saying that we have an even distribution. I'm not saying whole of Europe was the oak park. I'm just saying there's continuity here. Is my argument. I don't know if you buy it here. You feel free to not buy it.
Can we continue?
It's continuity, definitely. And you have to look at the Pleistocene as the cold and dry period, mostly, especially in modern temperate climate, also the calcium rich, because of this, the climatic setting. You have, much higher transpiration and the erosion. And so there was definitely much larger time for these grasslands to develop, to accumulate the species pool. So definitely, and I think it was the same, no matter if it was glaciated or not. I mean, in the area of the modern temperate climate, both hemispheres was definitely more drier. And over the glaciers, which was most of the Pleistocene, it was also 30% less CO1, which makes the very high humid stress for the trees. So they mostly can grow in the lowlands because not just the low temperature, but the low precipitation with a combination of lower CO1, though the grasslands have no trouble. So that's still definitely a longer continuity. And some of the Pleistocene forb species, grassland species are quite rare recently because they are sensitive. So we basically reduced their species pool. Yeah. And definitely go look to the white Carpathians and we'll find out that the species richness at a small scale is really a combination of environmental setting. It's a history, it's an environmental setting, really like the sandwich mid-domain effect. That you are in a very sweet part of pH, the humidity, and lots of really the forest species are penetrating. The most rich as well, the botanists, they are here quite a cherry pickers. They, really set the plot when it's absolutely the most species, and the species rich spots are very close to these open forests or big trees, which kind of make the source for really typical understory species. So this builds up the number of species. So it's in a kind of a biodiversity cherry picking, I would say. But still, the whole ecosystem is very species rich, and it's a combination of environment and also the continuity. And humans help to keep that continuity because the modern climate, the Holocene climate of that area, very much in favor of forest succession. So the humans, in some places, maybe if we didn't get rid of these few Holocene megafaunas, which are basically horses and the buffalo, let's say, just not many species, but they definitely could have supported small patches, but the area was colonized in a very Holocene, very early Holocene by humans, and they just, keep those grasslands open. Since then, we have evidence for that. So there's definitely a long continuity, and a combination of that one. So let's make it special.
Sounds exciting to me.
Can I?
Yes.
Little bit interrupt this and go further to your it was our package or
our package?
Yeah.
There's no our
okay, no, that your models.
Oh yes, maps.
This yes.
Maps, yeah.
And here there goes somewhere like species richness.
So this the species kind of the habitat quality that's captured in this biotic integrity layer and the way
this is only like vegetation or with animals.
No, this is the way we map this currently is we use presence absences of threatened species.
Okay,
so we have all so everything, birds, mammals, snails, insects, we have them, and obviously so it's very heavily kind of influenced by this indicator idea. That way we don't necessarily value one habitat type over another. We just say if you have some very rare species, threatened species, then we think this is likely an indicator that something else is also not as bad as somewhere else, right? It's not necessarily good, and it's totally ridiculous to give any place in Denmark 100 points, which is why I'm also here. But at least in Danish standards, that's our approach to mapping.
Because my point is, I'm my coaches. So in the Denmark, there is almost no really natural forest
So they are not in the list at all.
No.
So you basically can somehow map this. I know that they are not existing in Denmark, basically, but you can like have them because as Michael says about snails, the fungi is pretty much similar. There's a huge diversity of species which are only in the best forest, intact forests, and these forests are totally boring for botanists.
Exactly. Exactly.
Also for the entomology species. Yeah, close count.
Well, but I guess there could be some
right?
Some deleterious, right, click beetles and some.
Not completely, but they usually really like the sun.
No bees and butterflies, butterflies. Yeah.
So, you completely ignore the fungi, pretty much all the
fungi is often ignored.
Also with grasslands and everything. And my question is, if you integrate the fungi in your in all, the whole talk, how it will change?
Oh yeah, okay, very good question. So we are very aware that that this is an issue, and that not all species kind of groups necessarily just care about a rich herbaceous vegetation, right? But at the same time, and this could also be a criticism of the general idea of at all talking about integrity. I know that this is a criticism in the States. People that don't like this idea are usually ornithologists, right? So because birds are just more or less randomly dispersed across the landscape, so they never agree. Well, I guess they often agree, but they're just sad that it's not birds that we use instead of plants. I say that yes, you can say this, that there would be some groups that just don't overlap, but at the same time, I will say that I don't think that any ecologists, when they really sort of consider it at a large scale, would say that we have fungi over here, and we have plants over here, and we have birds over here, and then over there somewhere are insects, right? We do believe that ecosystem, right? We do study ecology, so there has to be species, interact and they rely on each other. And I will say that the reason, the way I hope that we get around, or that we sort of, I hope that this is the full package, right? I hope that the scheme that we're making here is. It doesn't exclude very old growth trees, right? It doesn't exclude more forested parts. It just says, it just basically integrates. We hope to sort of integrate it all together, right? So we don't say this is all very dry, warm microclimate. There will be more shady parts. It's also painted. It's basically painted in all the photos that in the background you have denser stands. And obviously there's no issue at all in including the very old oaks, right? You can have them in any grasslands, and you can find them
like open areas.
They're open, so you have some.
Really species which need like closed canopy, dark forests.
Yeah.
I don't say that it's like verticals.
I think. I know. So we do have also Danish researchers that specialize in fungi, and they do find there are some forests where you can find like semi-good, but not. But anyway, they say the same. They say remember that the colder and wetter microclimate in the closed canopy forest is also important. And I say that this makes complete sense because when they do this modeling, they, as I say, especially in the alpine region, but anyway, also in the lowland region, they do find a lot of closed canopy. So we don't want to say this is natural vegetation, right? We want to say this is natural vegetation and this is natural vegetation. But this is probably not natural vegetation in lowland areas. Sure. That's our point.
Yeah.
So I think so you mycologist, you must go to the alpine regions. You're welcome to be. You're welcome to. I guess subarctic is hard, but anyway, anywhere else you're totally. So, but it's a good point. We have to. Yeah.
May I continue with this? You said that you use the threatened species as an indicator. Yes. But the information, if the species is there to normal, sometimes you said something related to politician decision or something like that. Sometimes it's species which is on the margin of distribution area, or it's the typical species of some biotop which is diminishing or something like that.
Absolutely.
But if you want to study oak forest, so you need to have oak there, and that is not the threatened species, so something like that. So I wonder if some diagnostic species will give you more valuable information for that.
So very good point. And we have actually we're still working with this, and just this year we're updating it by kicking a lot of birds out. Because these birds are red listed in Denmark only due to population trends. So stuff like starling, European starling, I can't even remember necessarily the English names for them, but they are basically very common species, and they're distributed in all parts of Denmark. But due to very diligent work by a lot of ornithologists counting birds every year, for 100 years, they can say that the population trend is decreasing. But we don't think that, that's a real thing, and you should be aware of that. But it's hard to say, is that because Denmark was a lot different 200 years ago, much more, it's just like here, it's changed, right? Denmark was basically covered by one large heath 200 years ago. There were no trees. And the landscape was completely exploited, but not with intensive methods that we have today, but still exploited as hard as they possibly could. Right? They dug up juniperus trees to burn them in the stove, so everything was used. So obviously, species that thrived in this landscape, it's not crazy to think that they would go down. The question is that something we should be super worried about? So we are actually kicking out those species, and we're bringing in some diagnostic plants that are. For one, if we had the same data as we have with the birds, I'm sure that they would be much more endangered than they are, but we just don't. And the second is that they're much easier to work with as indicator species because we know now what the habitat requirements. Something like Troleus europaeus is not technically threatened enough in Denmark to be part of this map, even though there's like 10 sites left. So, but as long as they stay there, then we're like, okay, fine, then it's not threatened. So obviously that doesn't work. So your points about you have to nuance this. You can't go with a completely red-listed, non-red-listed, or threatened, non-threatened species, because you will get issues with that.
I will work with the diagnostics from the perspective of plants.
Yeah.
Yeah, and another point, I'm not sure about it. There are your species pool just of plants. When you show the ratio between forbs and trees, it is based on just the recent species. Or did you count somehow the extinct species? And if you will it change the pattern? Because I know that there are some studies from your group, this Eisenhardt, who showed that there is some cluster pattern in extinction of trees.
Yes.
Just trees of some particular lineages are extinct.
Yeah.
So maybe also the forbs or herbs which are extinct here have some particular trends or traits.
So good point. So indeed, it is Eisenhardt who with Jens Christian Svenning also that did this study of extinction patterns especially for tree species, and they found that this severity is much bigger in temperate Europe than it is in Asia or America. I think the short answer is we know extremely little about extinctions for herbaceous and grasses. So we have almost no evidence of extinctions. Yeah, I think so too. I think you're right. Yeah, so it's just they don't show up in the fossil record. So we basically say, were there any extinctions at all? We don't have evidence for it. Surely there must have been, because there are so many more forb species than tree species. So surely not all of them could have survived these both the climatic effect and the effect of megafauna. But we basically don't have it. I know that if you include the tree species, that doesn't change the overall pattern of this dominance of herbaceous plant species in temperate climates, but it obviously shifts it a little. It makes it a little less skewed. But still, as I said, in China, where the extinction, there was basically, there was extinctions, but not at all compared to like the extreme levels in Europe. You still have they still have insanely rich grassland communities in Eastern Eurasia, much more rich than the woody vegetation.
Maybe
any other questions?
I will ask people online.
Yeah.
Maybe if I can switch to present, or please, if there is someone online and has a question, now it's your turn. Or shall I have a look on that?
Yeah, maybe there's might be some questions.
Awesome. No, it's just translation. I don't know why it is going.
That's very cool. Direct transcript. Everything I've said is written down. Okay. On.
Maybe I have one.
Yes.
Little question concerning this nature indicator.
Yes.
And it's about like a differential species pool size of different habitats. Yeah, I could imagine that there is like, for instance, a lower species pool of plants in sand dunes compared to, say, oak forests. So how this is taken into account in this integrity calculation.
So the way we I mean, part of the field work that we're doing for the expedition is that we want to develop basically a so this is did I shut it off maybe no yeah this is obviously not from local mapping. This is a national mapping of available data. So and it's based basically on a lot of citizen science. So in Denmark we have very little nature, but a lot of people interested in nature. So all of it has been sort of recorded and not necessarily for the snails or the mushrooms, but the charismatic species, right? The butterflies and the flowers. So that's why we can sort of map it at a national scale. But I'm trying to develop a field method for biotic integrity, and that's where we rely on the plants, but we also will rely on the eDNF in the soil, and we will capture fungi and prokaryotes. And obviously, still we lack the bats and the birds and but nobody believes that you can do an all taxon approach to field sampling. Maybe 100 years in the future, we could just like sort of I don't know what we do, but we just scan and then everything comes in. But now we still have to get.
There will be nothing.
Yeah, it will be simple. It will be simple.
Nothing.
Dogs. That's true. Very good. Yeah. So, but anyway, so obviously it has to be a sweet spot between you can do this relatively rapidly and without being the best kind of expert in your specific field, or you can. Well, and at the same time, you have to get a very reliable measure indicator for is this habitat valuable for conservation or not. And the way we sort of try to capture all these ecosystems without giving precedence to the ecosystems with very large species pools. We don't want to be too distracted by the high species richness because then we obviously lose the gamma diversity if we only prioritize the grasslands. Is that I mean, coastal dune habitat also has threatened species, and that is it's not like you need 100 threatened species to be paint red. It's sort of we are very sort of open. You just have a couple, then you're in, right? Because that's also, unfortunately, that very binary sort of pattern that we know from our modern landscapes. It's not like you're uncertain whether this could be interested or not. You're usually, as an expert, very aware. Here, I might find something. Here, I'm definitely not going to find something. At least this might not be the case for Czechia yet, but if you're going in the same direction as Denmark, it will be the case. It's very much, there's no chance I'll find anything interesting because it's intensive forestry or intensive agriculture. Or here, you can see there's a shrub or two. Someone hasn't been in here optimizing in the last 5 years, so there's a chance. So that's why we are, if we took this measure and put it on Czechia, your whole country would probably be red, and you wouldn't know when to even do agriculture because you could probably find a threatened species. I don't know, but it's probably the same. It's probably very similar. But that's how we get around. And it's also sort of how we try to get around habitat type. And I know this is also kind of crazy, but we know that if you just rely on natural processes, flooding and herbivory, which is or sand drift, the habitat type that's there now probably isn't going to be there in 50 years. And that's both because it is like natural to have slow changes in vegetation cover, but also because we don't have as I said, we don't have the straight tusk elephant, we don't have the African hippo, we don't have the forest or the steppe rhino. We don't have we have cattle and horses, and you simply can't expect that cattle and horses can limit some of these very resistant trees, very quick growing trees. And that's a problem obviously because in our theory, until that day when we have elephants in Europe, we can expect to basically lose a lot of species if we don't do anything. So we are in this dilemma now where Well, we still don't have the elephants, so we should, I guess, allow that people go out with chainsaws or scythes or whatever else machinery that's developed for nature management. Or we just say, this is the novel biosphere. This is the new kind of reality for planet Earth, and it's simply too cost inefficient to have this intensive management. So we basically have to give up on some species. That's rough, but we argue that maybe on large scales, if we take this approach of just protecting and restoring, really like restoring the processes and then letting it go, we think on the large scale this will save more species than what we're doing now with very small sort of patch management where we have these little remnants of species. And this again is sort of a wild argument, but our idea is literally, and it's also inspired by our conditions in Denmark and in northwestern Europe, where we're very, very, I mean, we're back to the few remnants kind of habitats. And even if whatever we do, even like we set in with all the means to conserve these last remnant butterflies, it doesn't look like we can do anything. It simply looks like it's too late. So the populations have become too small, still suffering from extinction depth. Literally, no matter what we do, we might lose them. So that's also, I think, inspiring this sort of maybe a little bit more depressive approach to nature conservation. Little less, but also we believe obviously that this is an also exciting new future where we get sort of wild nature back in Europe. But this is more over in the conservation, like applied conservation side of things, than it is necessarily in the kind of the research ecology side of things. But this is basically what the map points towards, that we don't get extra points for people like very focused on the conservation of specific species, and it hurts to think about, because I really love these species. And the reality is, in my own sort of area, I do management, right? I do cut the freaking Alnus glutinosa that keeps coming up. Stay down, right? I keep cutting it down because I know, my Lucina butterflies and all that are there. But I know also that obviously this is not the future for European conservation. We can't keep going down with the little. So these are also things that we're struggling with. And if any of this sounds exciting, and you want to learn more and discuss this more, as I said, reach out, because we are working with these things right now, and it's exciting to get more and more kind of European perspectives on this, because I think this is we're in this together in Europe. This is a shared debate, right? We've pretty much done the same thing to our nature anywhere in Europe, and we have this bad reputation of kind of gardening our nature, right? So it's also that we have to think, okay, are we going to continue that, or are we going to try to make wild nature? And what is wild nature even? What is it even? So that's.
If you have a question, you have to give some sign here. That's Mikael.
Yeah, I want to say that, the game changed also, not because we don't have elephants, but we have so much nutrient load.
Exactly.
So 30% higher CO1 concentration than ever been since we have the record 5 million ago. So so many things has changed. Yeah. And the question is, do you have any new data from Denmark about the Amiens reconstruction? Because to my knowledge, all the paleontological data from the Atlantic coast of Europe, they are showing very coniferous humid landscape, because Amiens was warmer, it was more oceanic, it was higher level of sea level.
Yes.
So I mean, the pictures you saw, that's kind of a reconstruction, from
continental
Poland, mainly the flatlines, not that much Alps, not that much Carpathians, probably some Czech lands. So what's the Danish perspective?
The Danish, I do. So there is in this paper, there is, as far as I remember, there are one or two lakes from both, I think, from the British Isles, maybe from Ireland, which is very Atlantic, probably the most Atlantic we have, and also I can't remember if it's Danish, but at least very northern Germany. So, and I can't remember if it's on the North Sea side or the Baltic Sea side of Denmark. But anyway, they find, I think the general trend, which is a little bit surprising, is that you see a lot of heterogeneity. So you don't see a very fine gradient of going from more forest to less forest as you go continental. They were surprised to find that you do sort of, it's almost sort of random, that you find then this area, these 100 by 100 kilometers area, is surprisingly open compared to how west it is, and then you find some east spots that are more closed than you think. And I think that they also say or they do say that this heterogeneity is also an argument to say that these were, if it was climate drivers, we don't really understand the climate drivers because they're simply not sort of predictable enough to fit into our general ideas of the distribution of moisture or the distribution of. So this find of higher heterogeneity in the general structure between sites is also an argument that other processes have also played a very important role in shaping of vegetation. But I don't have unfortunately I don't have the figure, but yeah, so I could have shown that, and then it will see, this very general habitat of alpine regions being darker, but in lowland, in temperate, humid, pretty much across temperate, humid Europe, you have high heterogeneity. So you don't find these very nice, neat patterns of vegetation.
Yeah. So I'm just wondering if this can apply also for Atlantic coast, for Danish, landscape, because based on at least like original data, I would say that your baseline is the human conifers. Well, it's some probably open patches, sure.
Yeah, but it fits much more at least for the Holocene, we know it's very strongly fits the Swedish example I showed you of. But at the same time, there is Paleoloxodon's jaws in a Danish gravel pit. So somehow this close. I mean, so that's what we're struggling to combine is that this very close canopy, basically so close that an elephant the size of Paleoloxodon shouldn't be able to move 1 square meter. And what we see that elephants do to trees with basically harder wood density than Campinos and beech in Botswana, for example, we see that they do to these trees. And then we scale that elephant up 3 times, and then we put it into this beech forest. It wasn't beech then, but maybe Tilia, more with relatively thin bark. And we say, how does this? I mean, it simply doesn't fit the ecological, what we know ecologically about what these elephants do. They are very, very hard on trees. I just came from Botswana in January, and the people are worried down there. They talk about broken woodland, and they are desperate to be able to shoot these elephants because these elephants are basically removing trees, big mature trees, either by debarking or by literally just cracking them over.
Yeah, absolutely. So they are very important also for river alluvium management. So if you remove them, the river starts to erode and make the very steep and sharp edges or barks, which are difficult to cross for many animals. Yeah. So those are definitely important engineers. Sure.
Natcha has a question.
Yeah, but it was probably kind of similar or very related, and I'm also not a botanist, so the question was very simple. I was just surprised that like searching for the baseline for such an oceanic region going to the continental, and if there are places, for example, on the British Isles, which are similar, like could also answer your questions, or if they are like managed so intensely as the landscapes in Denmark.
That would be a terrible place to go for a baseline. I mean, they are basically the exact same as in Denmark. So you can go to the Scottish Highlands and they look natural, but they are,
So climatically, there is no place.
Climatically, there's no place. No. So Denmark is technically half continental, half Atlantic. So it's not like we don't have continental, and you can argue, I mean, who draws those maps, right? Who draws obviously, there is no such thing as a continental zone anywhere. It's all arbitrary. So we just draw the line somewhere, and you can draw more conservatively and make 100 different climatic zones in Europe, or you can make 10. But our point is, the species pools are exactly the same. So we are just nested inside this much larger species pool that you have down here. We just have a little part of it. And the question is, should we accept that little part, or do we make an ecological mistake by basically narrowing our field of view and say, no, these species are just what is natural in Europe, or in northwestern Europe. And our argument obviously is that we should. That's a risk, because then we basically put a hard limit on the restoration ambitions of northwestern Europe, which are and that's probably troublesome because then that puts all the pressure of conserving species on you guys. You basically have to conserve all European species then, because Northern Europe is saying, no, this is not natural to have. We just need this, right? This is what we're conserving, and at the same time earning money on cutting down these trees. So it's also about we should. I'm just I'm curious. Are we sort of putting a responsibility away from ourselves in Northern Europe? It wouldn't be the first time that we sort of because we already say India and Africa, you preserve the tigers and the lions, right? Even though. I mean, not tigers, but lions, hyenas, leopards, all this should be in Europe, right? They were before the late Pleistocene extinctions. We have cave lions, and we literally have the same.
Also the glacial time.
Also,
so you have to wait for them.
Yeah.
You have to wait for them.
Yeah.
Be honest.
Yeah. True. We have to wait for them, but we have our troubles with the wolf even. The wolf is even a little too much.
And bears.
Yeah.
Bears.
Don't talk about bears. Yeah. No. So it's also about sort of let's make sure that we're lifting the responsibility that we have if we claim to really care about these species. That's also motivation. Yes.
So do we still have some animals that we can use for this restoration project, or they're just too small? Because there are some bisons left in Białowieża and it's pretty much still forest.
Yes, it very much still forest. Yeah. So this is a very good question. I think the question of herbivory, sort of both ecology and management, is something that I actually spend most of my time writing about that. Both sort of what can we expect from the baselines, but also how do we realize it? I mean, what's impossible? What's possible? What are the current barriers for this? And it's a pretty big subject. So I don't think necessarily. If you guys don't know, we can talk about this. But the Białowieża example is a good example because you have European bison in there, but at the same time, the way that it's managed is very, very, very far from any natural situation, right? It's fed in the winter, where we know that from the studies of these animals, that's when the impact on woody vegetation is hardest. So you skip that, right? So you just have them eating. Basically, you treat them like cows. You have them eating the nice soft grass in the summer. And then when the winter comes, you throw lots and lots of hay. And at the same time, you have a very small population, because if the population grows too high, there's no fence around Białowieża, so they can just run out on the agricultural fields. They do already. But then you have to be in agreement with the local farmers and say, you can tolerate this amount of damage. So that's where we'll keep the population. And they do that not only in Białowieża, it's the exact same management in Yellowstone National Park, which is in all our minds sort of this perfect wild system. They shoot 1,000 bison each year because they don't have it fenced, and the bison are not stupid. They know what's nice and nutritious. So they want to go out on the surrounding cornfields or in the surrounding livestock farming. And obviously the farmers do not tolerate them. So the compromise is you suppress the density of bison, right, to a level where they basically stay inside the park and don't feel the need to immigrate. And obviously, I mean, this is not natural, right? So what we know from Africa, which is almost the only place where you actually resist the urge to manage these animals, is that they, just like any other system, they grow and grow and grow until they reach carrying capacity for the ecosystem, especially the large mammals are too big to be regulated by predators, and then they die of hunger, right? Just like any other natural system. So you have to someone has to die before there's room for new individuals. And this doesn't happen anywhere in Europe. So we don't have really anywhere in Europe where large herbivores, we have it a lot with small. So millions of mice and rodents die of hunger each year in Europe. Nobody cares, right? But if a horse dies of hunger, everybody goes crazy, right? Even though that would be horses are small enough for the cave lion to sort of probably have a pretty big impact. But then you go to the aurochs and the bison and the rhinoceros and the elephant. They don't care. So the young will be eaten, but very rarely does a mature female fertile elephant get killed by anything. So that means their density is controlled by the carrying capacity. They are bottom-up regulated, which means the way that they die is they die from hunger, right? They get old and die from hunger, or they die from hunger as fit animals in very harsh years. So until we have systems where we actually let large herbivores die from hunger, we should be very careful about the conclusions we take from their actual impact. Because right now we just have very low densities. Even the deer, which are we actually discussed this yesterday, Jacob. The wild boar or the deer, we are sort of the general agreement is there's too many, right? It's too much. There's too many deer. We have to be sure to make sure to kill a lot of deer. We did studies in Denmark looking at how many deer there actually are versus how many deer you could expect when you look at the actual food in our wild systems. And the difference is, 10 times. So we have 10 times fewer deer in our natural systems than they actually could support. And we haven't done it for wild boar, but my claim is, and this might be a bold claim, my claim is you probably have fewer boar than would be natural. Right? And this is not, I can say that easily because they would just go and ravage your agricultural fields, but I'm talking about in your natural areas. We usually, the trend in everywhere in the world is we tolerate fewer mammals than actually are natural. And especially the larger they get, because the larger they get, the more troublesome they get. Even with totally natural density dynamics in Bielorussia with the bison, I don't think it can necessarily limit the Capinus dominance. Mm-hmm. But I'm also saying that the European bison with 1,000 kilos average, so for the big ones, is 12 times smaller than the trade-tusked elephant. So
just to interrupt you, so this means pretty much that there is no way how to use megafauna because you need to use some fence.
Yeah.
At least fence the forest or fence the field.
Exactly.
That's problem with migration of another animal.
Yeah.
So this is like over.
No, you can do. I mean, you can do fencing. You can do.
I don't think so. Like for the.
No, wait. So we've actually researched it. So we did a paper in Denmark where we said, okay, let's say you do want to do fencing, and you can basically connect all natural habitats in Denmark by corridors and river valleys and stuff like that. So the fencing issue is not a biological one. It's one in our minds. We don't like the fences, and they're expensive.
Because there is a fence in the Białowieża between the Poland and
yes,
there is a fence, and I know that people from Białowieża go crazy about them because a lot of animals die on this fence.
Yes, but animal deaths do make us go crazy, but it's not necessarily a biologically reasonable thing to do.
Yeah, but if you have small population only in that Białowieża left and you fence.
Obviously, yeah. So an example. So if this was the talk I was going to give today, I would have a lot of good examples. But I'll give you one example in regarding to these fences. So it's a mistake to think that fences necessarily kind of make it impossible to have sustainable natural populations of herbivores. And the example I'd like to make is from an island off the east coast of Canada. So we're talking in the northern Atlantic Ocean. Terrible place to be. So this is terrible weather, right? It's a dune island, Sable Island it's called. You can look it up after, of around 3,400 hectares. Mm-hmm. I can't remember exactly how big Bielorussia forest is, but maybe I would claim it's about the same. It's over 1,000 hectares.
It's definitely
right. Yeah. So on this island in the 18th century, some Europeans kicked off some horses to go on that island, and it's literally made of dune sand and dune grasses. So it's a horrible, terrible place to live. But ever since 18-something, there's been a population of wild horses with no management at all from humans, right? And every year, 20% of the population die from being a mix of old and sick and starving. But there's no trend in, they've studied them genetically, and there's no trend that fitness is falling. So at least, and this is only 200 years, right? So, but at least from that example, the only example pretty much from temperate climates we have of a population of, which is also important this is important to pay attention to, the only example of a population of large herbivores that are restricted to an area with no management shows that at least for 200 years, 3,400 hectares is enough for a horse population. So I'm not saying that's supernatural. I'm saying, well, islands are natural, right? But we also know of examples where deer immigrate to a small island, and then wolves immigrate, and they kill all the deer, and then the wolves die. So we know that these patch dynamics are normal for small islands. But I'm just saying, the baselines I'm talking about are also very intense in how we think about herbivores. So until I'm just saying the only example of it shows that they're still going. So I'm not saying anything other than we don't have evidence that proves the opposite. And I don't want 100 hectares fenced and then call that a natural. Well, nobody wants that. But I'm just saying, in Denmark, we have agreed on 5,000 hectares. But again, we just pulled that sort of out of our. I mean, we don't have any evidence saying that 5,000 hectares is enough to have a natural. Literally, Sable Island is the only example of this from at least from contemporary science. So,
afraid the time is.
yes, the time is running. This was a whole different. Something else, but very exciting.
Oh, thank you very much.
Thank you.
Thank you very much.
Thank you.